The mapping w equals f of z, which is 1 over z, is called an inversion. It maps the interior of the unit circle in the z-plane to the exterior of the unit circle in the w-plane, and vice versa. So this is the picture. Let's see how this works. Any point in the interior of this unit circle will get mapped to a point outside the unit circle in the w-plane. And any point outside the unit circle in the z-plane will get mapped to a point in the interior of the unit circle in the w-plane. So let's get the image of this point, which I'll just call x plus yi. It's got the property that its modulus, its distance to the origin, is less than 1. So this is going to be 1 over x plus yi. Now we want to write this as a single complex number, so we multiply above and below by the conjugate of the denominator. So in the denominator we're multiplying x plus yi by its conjugate. That's the same as squaring the modulus of x plus yi. That is x squared plus y squared. So that's the distance of x plus yi to the origin. Now let's look at the modulus of this quantity here. Well, we just square the real and imaginary parts. Now we have this common denominator here, so we have this here, and we can cancel one of these, so we get 1 over x squared plus y squared. But we can see here that for this complex number that's inside the unit circle, the modulus x squared plus y squared is less than 1. So the distance from here to here is less than the radius of the circle, which is 1. So for the modulus of the image, we get 1 over some quantity that's less than 1. So 1 divided by a number that's less than 1 is obviously greater than 1. So the modulus of the image of this point is greater than 1. So the image of this point must be outside the unit circle. Actually, you can see that the x value of this point is related to this here. It's just x is scaled down by this quantity. So the x value is going to be positive. See, the x value of this point is positive, so the x value of the image is also going to be positive. The y value changes sign. It's plus y here, then it becomes minus y over x squared plus y squared, since y is positive in this picture. So the image is somewhere down here, but the main thing is that the image point is outside this circle. The distance to the origin is greater than 1. Of course, an easier way to see this is to use Euler's formula for a complex number. So if our general complex number that's inside the circle is r e to the I theta, then 1 over this is 1 over r e to the minus I theta. Okay, 1 over e to the I theta is e to the minus I theta. So r is the modulus. So if r is less than 1 to begin with, well, 1 over r is going to be greater than 1. For a point outside the unit circle here, say this point here, r is greater than 1. R is just root x squared plus y squared. It's just the modulus. So 1 over r in that case will be less than 1. So the image of a point out here will be some point inside the unit circle. Now if we are going the other way, say, well, we have that w equals 1 over z to go from the z plane to the w plane, but if we want to go back the way, we see we get z equals 1 over w. So we put 1 over our number in the w plane to get the image in the z plane for going the other way. But 1 over w will have the same form as 1 over z, of course. So it'll have this form here. But we call w u plus iv. So when we get 1 over w, we have the same form as this, but we replace x with u and y with v. So we get this here. Let's consider the image of a line through the origin in the z-plane under the mapping 1 over z. Since any line through the origin has the form y equals mx, where m is the slope of the line, then a general point on the line will have coordinates x, mx. So for that point we have the complex number x plus mxi. So we want to get the image of this general point on the line, so we want, under this mapping, we want to put 1 over z. So this is our z. So we want to write this as a single complex number, so we multiply above and below by the conjugate of the denominator. So the denominator will be the square of the modulus of x plus mxi. So we square the real part and then we square the imaginary part. So now we can note down the real part. The real part is just x over x squared plus m squared x squared, and the imaginary part is minus mx over x squared plus m squared x squared. So the real part of the image is called u, and the imaginary part of the image is called v. Now what's the relationship between u and v? Well, that relationship is the equation of the curve that is the image of this line. Well, it's clear that we can get v from u by multiplying u by minus m. See, that's the only difference, is minus m stuck in front of u here. So v is equal to minus mu. But this is the equation of a straight line through the origin of the w plane, and that straight line has slope minus m. A line with a slope of minus m is got by reflecting a line with a slope of m through the y-axis. Actually, this angle here will be the same as this angle here. Well, if we call this angle theta, then the slope of this line is the tan of theta, because theta is the angle measured anti-clockwise from the positive x-axis to the line. Whereas the slope of this angle here is the tan of 180 minus theta. Okay, to get the slope of a line we get the tan of the angle measured anti-clockwise from the positive u-axis in this case. But the tan of 180 minus theta is the same as the tan of theta, or sorry, minus tan of theta, which is minus m. So this mapping has the effect of reflecting the line through the y-axis. Next we will consider a line that does not pass through the origin. The general equation of any straight line is ax plus by plus c equals 0, where a, b and c are constants. If this line is not to pass through the origin, then c cannot equal 0. Because if c was 0, then if x is 0, y must be 0, to get 0 on the right hand side. But we don't want y to be 0 when x is 0. If x is 0, y will actually be minus c over b. So this is y, and if c is not 0, obviously this is not going to be 0. So this is the y-intercept of a line whose equation has this form. Let's consider a general point on this line. So the x-coordinate we just say is x. What about the y-coordinate? Well, we just make y the subject of this. So we just shift ax plus c over and we get minus ax minus c, then we divide across by b. So as a complex number then, the real part is x and the imaginary part is this here. So here is a general complex number on this line. So the image of this complex number is 1 over it. And we want to write this as a single complex number, so we have to multiply above and below by the conjugate of the denominator. Now the conjugate of this is got by changing the sign of the imaginary part. So when we multiply underneath, we just get the square of the modulus of this complex number. So that means we just square the real part, square the imaginary part, and sum. So what's the real part of this? Well, that's just x over this. So that's u. So the real part is just x over this. The imaginary part is the coefficient of I. So v is going to be ax plus c over b divided by this denominator. Here are u and v written out again. Now what's the relationship between u and v? Well, we see that if we multiply u by a over b, we will nearly get v. Well, we'll get this term here. A over b times u will give us all of this here. The problem is we still have c over b over this thing. So we need to somehow deal with this denominator. It's a bit of a problem. So v is not simply a over b times u, because we've all of this to deal with. However, if you notice the numerator squared here is x squared, the same as this term here, and the numerator of v squared is ax plus c over b squared. So that suggests that if we square this and sum them, we can somehow get the denominator in terms of u. So let's look at u squared plus v squared. We square this, and we have all of this denominator squared. I just call it d squared. I just call it denominator d. And up here we have ax plus c over b squared divided by d squared. Now if we add these, notice what do we get on top? We just get the denominator. That's d. So we d over the common denominator d squared, so we just get 1 over d. So that tells us that d is 1 over u squared plus v squared. So if d is 1 over u squared plus v squared, if we multiply above and below by u squared plus v squared, we get u equals u squared plus v squared times x. And over here we have the numerator ax plus c over b divided by 1 over u squared plus v squared, or multiplied by u squared plus v squared. So we make x the subject of this, and we will also make x the subject of this. Then we'll equate the two results to get the relation between u and v. So we start by multiplying both sides of this by b, so we'll get bv on the left hand side. Then we divide both sides by u squared plus v squared. So that'll leave us with ax plus c on the right hand side. So we have to subtract c and then divide all of this by a to get x. So now we just equate this thing with this thing because they're both equal to the same thing, namely x. And here's the equation connecting u and v. So we multiply both sides of this equation by a, and I brought the right hand side over to the left hand side. Okay, next we multiply all of this by u squared plus v squared. And we get rid of the u squared plus v squared denominators. Finally, we divide all of this equation by c, and we will write the squared terms first, then the linear terms u and v. You might recognize that this equation has the form of the equation of a circle. So x and y are the variables, well, in general, but here the variables are u and v. C is actually where the circle cuts the y-axis. If we set both x, if c is 0, then you can see that 0, 0, x equals 0 and y equals 0 will satisfy this equation. In other words, 0, 0 is on the circle. So if the constant in the general equation of a circle is 0, then the point 0, 0 will satisfy this equation. So this must be a circle that passes through the origin of the w plane. Now if a circle is given in this form, then h comma k is the center of the circle. So if we want to, we could write down the center of this circle in terms of a, b and c. I'll just note it down here. So we just get half the coefficient of u and change the sign. Okay, because minus 2h is the coefficient of x in general, so the independent variable here is u. So the center is actually minus a over 2c, comma, and then we have the coefficient of the dependent variable to get the y value, or the v value here, so it's going to be b over 2c. We could go further and get the radius. The radius of a general circle is root h squared plus k squared minus c. So hk is the centre. C then is this constant at the end. Well, c will be 0 in this case. So the radius in this case is just root h squared plus k squared. So we'd square this and sum them. So here it is. We get root a squared plus b squared over 4c squared. So anyway, the image of a line that does not pass through the origin of the z plane is a circle in the w plane that goes through the origin.